I'll be happy to admit it. I do 90% of my mobile app development using my browser here, especially when I'm working on screens that don't require the native capabilities of the mobile device. The convenience of the Chrome developer tools along with live reload is just too hard to beat. Having said that, you must set aside time to test with an actual mobile device. In particular, it is just too easy to find situations where the performance looks fantastic on my desktop browser here using my powerful development machine, only to deploy the app to the device and find out we have significant performance issues when running on the device. Let's work through one such example now, and then we'll address how to fix it. So if we look at the standing screen here, running on my normal desktop browser, we can see there's a ton of teams in here. It's a huge list of teams. And the performance appears just fine. Now let's see what the same screen looks like on the actual device. Here I am now running this exact same screen on my actual device. So this is not a simulator. I'm actually holding my phone in my hand and I'm reflecting the screen onto my computer here. Same screen. If I use my finger to start scrolling down, you can see it's actually horrible performance. It stops and starts. I can scroll for a while and then it's very choppy and it's really a horrible user experience up and down. And what's happening here is the mobile browser is having a difficult time keeping track of these many items in the DOM. When we typically have pure native applications, they have controls which add and remove items to the list using a virtual scroll. And all this is happening on your behalf behind the scenes. Well, with the Ionic framework, we now have a virtual scroll here as well, so we can approach this situation in much the same way that a pure native developer would do it. Let's implement virtual scroll for this list now to see how we can improve the performance of this screen on the actual device. Here I am in the standings component. And if you remember previously, one of the things we had to do was we had to use this Lodash query here to take what was a flat list of standings, and we used the group by on the division here to make it a hierarchical data structure so we could get the grouping for each standing. When working with a virtual list, we actually need a flat structure. So the first thing I'm going to do is I'm going to comment out this line completely. We won't be using all standings. Let's comment that out too. We're just going to use what we already have here, which is the flat list of all the standings together. Now let's flip over to the HTML page. And here's our Ion list that we're using right now. We can see all the standings in here. And let's just hit the hard return a couple times to move that a little bit out of the way. And we're going to create a new Ion list. And inside this Ion list, we're going to add an attribute here for virtual scroll. And we're going to set that equal to that standings property that we already have. Inside the Ion list, we're going to add an Ion item. And in this Ion item, we're going to add an attribute called virtual item. And inside, we're going to say let team. You can think of this sort of like an NG4. We have a list here for our virtual scroll standings, and this is an array of teams. So each team in that list is going to go on a virtual item here. So that's why we say let team. This is representing one instance of a team of this entire standings array, which is an array of teams. Now what I'm going to do down here on the old list, we had the Ion item here where we were doing let team as part of an NG4, and we had 3 rows in here. Here's an Ion row for the team name. Here's an Ion row for the header columns. And here's the third Ion row for the actual values. I'm going to take these 3 rows right here, and I'm going to cut and paste them into this Ion item. And let's format. Now the other thing I want to put in the Ion list is another attribute called approx item height. And inside that, we're going to set it to 132 pixels. This is used to help calculate the height of the scrollable area and how many cells should initially be created. Now, a lot of people look at this and think, wait, shouldn't my CSS be determining the size of each item? And yes, it should, and it is. This approx item height attribute is used as a performance optimization to calculate the height of the scrollable area that those items are inside of. Let's run the app on the device again to see how performance may or may not have been affected. Now here I am back on my mobile device. We're back on the same standing screen. Now let's see how the performance is. As I go through, you can see there's not that same choppiness that we had before. In fact, it's performing really fast, and I can get down to the bottom of the screen with a few swipes, and there I am right down at the bottom of the screen. So the performance is actually pretty incredible right now, and this really looks a lot more like what we'd expect from a native app. That's the kind of performance we have right now, which is really great. This is very promising. However, even though performance is now much better, we've lost all our nice division headers that we previously had. And this happened when we moved back to a flat structure. So let's see how we can fix that now while still using the virtual scroll optimizations that are giving us this native-like performance improvement. Back on the standings page, there's a couple of things we need to do to allow us to have headers in a list that's using virtual scroll. First, inside the Ion list element, I'm going to add a new attribute called header fn for header function. And we're just going to refer to a method named getHeader. The other thing I'm going to do is remember this original list we had down here. I'm going to take this Ion item divider and I'm going to cut and I'm going to paste that right up here. And just like we had a virtual item attribute down here, we're going to add a virtual header item up here. And we'll just say let header, similar to how we had let team down here. Now division.division name, that only existed when we had the hierarchical data. So we're just going to replace this with header, which is referring to this variable right here for the header. So you can see that we've basically taken all the structure that was up here and we've moved it to the list up above. So we don't even need this anymore. It's essentially an empty list. Take that out completely. Now we've just referred to this getHeader method here. And this is called for every row. And it's used to determine, do we need to add an Ion item divider here, which is our header. So let's flip back over to the standings page. And we're going to add this getHeader method right here. It's going to take in a record index, and then look at all the records. First, let's just do a contrived example. I'm going to say if the record index, and we'll say mod 10, so if the record index is divisible by 10, return header. Otherwise, we'll return null. Let's just run this first in the browser. So here we are in the browser. We see a header right here. If we scroll down about 10, we see another header. If we scroll down another 10, we see another header, and so on and so forth. So we can see that function's getting called, but right now it's not that helpful because we're just arbitrarily putting headers in here every 10 records. Let's see how we can fix the logic to actually put the division names in there where they're supposed to go. So we have a couple of conditions we need to check for. First, if the record index is 0, that must mean we're on the first team, which is the first division. So yes, we want to return the actual record in that case. So instead of saying header, we'll just say return record.division. The other condition we want to check for, let's say we're not on the first one, so we would have an or here. And we want to check is the division of the current record not equal to the one that came right before it. Now with that simple logic, let's see how it looks. Now here I am back on my mobile device. I'm holding my phone in my hand, and we can see the first division there is 3rd grade. And if I scroll down, we can see there's 5th grade black. Here's 5th grade white. There's 6 black, 6 white. And now we can see we've got the divisions in there exactly where they're supposed to go. We still have good performance. The scrolling is smooth. We're getting native-like performance. I strongly encourage you to incorporate virtual lists, which gives you virtual scrolling capabilities into your app. Your users will thank you, and your performance will be outstanding.